Alright, so today we're talking about additive and multiplicative relationships. And I think you see the word add and multiply there. So obviously we're going to be talking about adding. I guess that does look kind of like a multiplication sign. And multiplying. Okay. And at this point, by this point, sorry, finding the autofocus button here. There you go. You should understand that you can add positive numbers and you can add negative numbers. And you can multiply whole numbers and you can multiply their inverses. So you can use the words adding and multiplying to describe subtraction and division. Because you can add a positive, which is like adding, or add a negative, which is like subtracting. You can multiply a number, or you can multiply, which is multiplication, or you can multiply its reciprocal, which is division. So these relationships have a lot to do with something you learned a long time ago, in maybe second or third or even first grade, about input-output machines. And it always makes me happy to draw some complicated machine. So if you want to take some time to draw your very own complicated machine, feel free to do so. I'm going to pause and work on mine for a minute. Alright, so I've made myself a nice little machine. And the idea of an input-output machine is if you put a number in, like we're going to say we put the number 2 in, okay, the machine is going to give us a certain number out. And whatever the machine gives out is going to have the same relationship to what it put in. So this machine right here, if I put in 2 and I get out 4, this could be a +2 machine, or it could be a ×2 machine. Okay, so with just one number in and one number out, you can't tell what the machine is yet. So that's why we tend to look at tables. Okay, and in this table, I'm going to say this is the in side and this is the out side. And then we're going to do the same thing over here. Okay. This is the in column, and this is the out column. Okay. Only as we're getting more advanced, and we're not talking just about machines and tables anymore, we're now saying that we put X in and we get Y out. So X is the number we put in, Y is the number we get out. Okay, so in my examples, I put 2 in and I get 4 out. Okay, so if this were a +2 machine, then if I put 0 in, if 0 went in and this was a +2 machine, then I would get 2 out, right? If I put -2 in, and this is a +2 machine, -2 + 2 would be 0. Okay, so if I put, so this would be if the rule is +2. Okay, so this would be a +2 machine. And of course over here I'm going to do a ×2 machine. If I put 0 in, and this is a ×2 machine, then 2 times 2 is 4, and if I put 0 in, 0 times 2 is 0. If I put -2 in, and it's a ×2 machine, well, -2 times 2 is -4. Okay, so this one over here is additive. Okay, so this is my additive machine. And this is my multiplicative machine. And there's a couple of things that I'm wanting you to notice about my machines, okay? The first thing I want you to notice is what happens when you put 0 in, okay? All right. When you put 0 in, let me sharpen this pencil real quick. That didn't work. Hold on. Let me pause and I'll sharpen. All right. Much better, except now I think it's too sharp and it's going to break, but, you know, I'm going to go ahead and break it a little bit. Okay. So, the thing to know is when you put 0 in a multiplicative machine. So anytime you put 0 in and then you multiply 0 by something, you're always going to get 0 out. When you put 0 in a multiplicative machine, you get 0 out. Okay? When you put 0 in an additive machine, unless you're adding 0, you're always going to get something else out. And if you have a +0 rule, then you're really just saying whatever you put in, you get out. So that's saying, you know, that we're just going to call that something different because you're not even adding anything if you're adding 0. Okay, so why does this matter? Why do we care whether we get 0 in or we get 0 out? Okay, so I'm going to skip a little bit of space here, and I'm going to use the bottom part right here to make a little bit of a graph. I'm going to try to get 4 lines on either side. Okay, these I think I'll just do. Yep. All right, and I'm going to let each of these be 2, -2, -4, -6. Okay, this is +2, 4, 6, 8, and this is -2, -4, -6, -8. Okay. So now let's look at my additive. Okay, where x is 2, y is 4. So this right here, oh, I should put arrows on either end because they keep going forever. Okay, this is my x-axis. This is my y-axis. Okay, so if x is 2, then y equals 4. Oops, sorry, get a little focus there. All right. If x is 0, then y equals 2. If x is -2, then y equals 0. Okay, and I can keep this going because I know the rule's +2. So 4 + 2 would be 6. 6 + 2 would be 8. -4 + 2 would be -2. And -6 + 2 would be -4. And can't quite find a ruler around here, so I'm just going to use my Queen of Hearts card to draw this line. Okay, and lines keep going in all directions. Okay, so there is the graph of my additive relationship. Okay. Hold on for some more pencil sharpening. All right, so now for my multiplicative. Okay, where x was 2, y equaled 4. So this is where my 2 lines intersect, right? Okay, but where x was 0, y was also 0. Okay, and where x was -2, y was -4. Okay, and let's go ahead and add on with the ×2 rule. 4 times 2 would be 8, and -4 times 2 would be -8. Use my ruler or my Queen of Hearts card to make my line. Okay. All right. So what I'm wanting you to notice is that the multiplicative relationship intersects the origin. Intersects the origin. This is important because if I could show you any line, and if you saw that it went through the origin, if it went through 0, 0, well, only multiplicative relationships are going to give you 0 in, 0 out. So if a line goes through the origin, it's multiplicative. Okay? If it doesn't, then it's additive. Okay? The final thing I want to kind of show you is how we put these into kind of equations. And I guess I'll do it down here. I left myself room here, but then I wrote it over here. So, okay, right here. So in this case, y equals x plus 2. Right? I put in 2 plus 2, and I get 4 out. Okay, I could have flipped it. I could have said x plus 2 equals y, but it's the same. Okay, but I'm not always going to be adding 2. So the way that I write this, if I want to say any additive relationship, is I put an A right there. Okay, so what I'm saying is the y is the sum or output. Okay, the x is the addend or the input. Okay, and the a is some number that's the same. Okay, so these two will change, but the a will always stay the same. So like in this equation, x could be 2 or 0 or negative 2, making y 4 or 2 or 0, but the a stayed 2. Okay, so the a is just whatever the number is that you're adding. Okay, all right. Over here, with the multiplicative relationship, what I had before was y equals 2x. And remember, when I have a number right next to another number, I multiply. Okay, so that's saying 2 times x. We don't write it that way because it looks funny to have double x's. Okay, but I didn't have to use 2 for a multiplicative relationship. I could have used any number, and so any number is represented by the letter A. Okay, and in this case, we're saying that y is the product or output. The x is a factor or the input, and again, that A is the same number every time. Okay, in my first example, it was the number 2 every time. Okay, so that is kind of your introduction to additive and multiplicative relationships. It should look just like tables with rules. Like the rule here was plus 2, the rule here was times 2. But now, instead of calling them tables or input-out machines, we're calling them additive or multiplicative relationships.